Hi, Algebra 1B students. It's Miss Carol again, and we are on the last lesson for Project 2. We're on Lesson 10. We've got 5 questions to cover today, and once you do this, you can submit your Project 2 and hopefully get a really good grade. All right, Melina's height above the water in feet after jumping from a diving board is represented by the function f of x equals negative 16x squared plus 8x plus 48, where x is the time in seconds. She is interested in determining the time that she reaches specific heights and thinks that she can use an inverse function to figure it out. Use your knowledge of inverse functions to answer the questions. Okay, so we've got this function that we know is a parabola, right? Let me get my pen over here. And it's going to look something like this. She's going to start up here at 48 feet, and she's going to jump up, maybe hit 50 feet, 49 feet, and then somewhere around 2 seconds, she's going to hit the water, right? And then this is negative time over here. So this is time, and this is height, or we could say that's x, and that's y, okay? Well, we can do an inverse function. We can utilize inverse functions only when a given input will only yield one output, okay? So, and let me read this correctly. I wrote it down because it is kind of confusing. Invertible functions, for invertible functions, each input must have unique outputs, okay? So, if there are 2 inputs that both have the same output, we cannot use that as an invertible function. So if I have something like a straight line, okay, every single input for this line is going to have a unique output, okay, being that our x values are independent and our input, and our y values are dependent and our output, okay? So a parabola, though, is different, all right? So what I want you to recognize here is that I am going to have the same outputs for various inputs, okay? So, let's say that at 2 seconds, I'm at a height of 10 feet. I might also be at a height of 10 feet at, negative 1 second, okay? And negative 0.5, I might be at 20 feet, but I also might be at 20 feet at 1.75 seconds. I'm not sure of those exactly, but what I'm just trying to demonstrate is that this symmetric parabola has a lot of matching outputs. Like, with the exception of the vertex, there is a matching output point on each side of that parabola. And so if we want to use an inverse function here, the only way to do it is to limit our domain, okay? I have to find where my vertex is, and I have to say, I can use this side and only this side, or I can use this side and only this side. But I can't use both sides and be able to use an inverse function to figure out my height, because I'll get, well, not to figure out my height, to figure out the time it takes me to get to that height. Because what'll happen is I'll say, okay, well, where do I end up at, let's say 47 feet? Well, I'll end up at 47 feet at a negative time and at a positive time, I've got 2 different times that'll work for. Even if, let's say that my ultimate height was 50 feet, and I wanted to find out when I hit 49 feet, well, I'll hit 49 feet at 0.5 seconds and at 1.5 seconds. I don't know exactly where those are, but there's going to be 2 different times that are going to give me that same output, which is why we have to limit that domain. And so if she really wants to figure out at what time she'll be at certain heights, she has to say, okay, I'm going to be greater than the vertex, or I'm going to be less than the vertex. So hopefully that makes sense. And let's see which one of these answers kind of fits with what I've just written there. So the function actually is invertible, but it's invertible for specific intervals, okay? It's not invertible for any of the domain, and it's not invertible for the entire domain, all right? It's only invertible for specific domains. And if you forgot, domain is our x values. So for very specific intervals on the x-axis, we can be invertible. We can look at the output and figure out what the input would have been. Hopefully that makes sense. It's a little bit confusing for sure. All right. So over which specific intervals is it invertible? And so what we need to do here is figure out where our vertex is. And so we have to go back to that initial function, negative 16x squared plus 8x plus 48. Okay. And remember that the x value of the vertex, which is what we're looking for here, is going to be negative b over 2a. So in this case, that is negative 8 over 2 times negative 16, which is, the negatives cancel out, 8 over 32, and that simplifies to 1/4. Okay, so we need to look at these intervals. We know that we're going to hit that vertex. Let me just draw this out. We're going to hit that vertex right here at 0.25. Okay, this is terrible drawing. All right, but this is our demarcation. We can go above 1/4, we can go below 1/4, but we cannot include the entire range. All right, so let's see which intervals fall within that. Certainly not all real numbers, okay? But if 1/4 is less than x and x is less than 2, and 2 is out here, yeah, this one will work, okay, for sure. A value of simply x less than 0. Okay, let's see, x less than or equal to 0. 0 being here, let's see, we should be able to do that, but that's not actually listed as one of the answers. It should be, because you could use that range. You could find anything less than 0, but it wouldn't give you this piece right here. So I think that's why they're saying that one won't work, but it's not like you're going to get duplicate values if you go out here. So this x less than 0 is not one of the answers. I believe it's because it excludes this little piece right here. X less than 2 won't work because that includes everything out here, and it will include some duplicate values. Okay, 0 is less than x, which is less than 1/4. Oh, I know why this won't work, because they just don't want to include negative time here. So this certainly won't work there. But this range is actually positive time and something that'll work. okay? It's less than your vertex, but it's still in positive time. X greater than 0 can't work because it includes duplicate values. It includes this side and this side, okay? X less than 1/4, that'll work because it includes this set of positive values. And then of course, X greater than 1/4 is just this side. So hopefully that piggybacked with what I was talking about initially. That all makes sense. Let me just clarify which one of these should indeed be checked here. 0, these 3. So just to make sure that we're looking at only one side of the parabola at a time, and that we're not just looking at negative values. That's the only reason this x less than or equal to 0 won't work. Okay. Question 3, which situations describe the intervals where the function is invertible? Okay. Let me just make sure that I have these. Okay. Any interval of time after she reaches her maximum height, right? So that's after a quarter second. So that's true. Any interval of time before she hits the water. No, that won't work because that includes on the way up and on the way down. Any interval of time after she jumps. That's the same as the previous one. Any interval of time before she reaches her max height. So that's x less than 1/4, which we decided would work. And any interval of time between when she jumps off the board and hits the water. Well, that's the same as the other two that didn't work. So the only ones that'll work are the intervals of time before or after she reaches her maximum height. Not together, before or after. Okay. 2 essay questions here. Explain why the function f of x equals negative 16x squared plus 8x plus 48 is not invertible on the interval 0 is less than x, which is less than 2. So this interval will not work because there are more than one. There are more than one input. There is more than one input. Let's use proper English. There is more than one input that delivers the same output in that interval. It is not 1-to-1. So an example would be there is more than one time when she is at a height of 48 inches. Okay, hopefully that makes sense. And the last question, she wants to know how long it takes her to hit the water after jumping off the diving board. In other words, she wants to determine the time at which her height is 0. And so I am going to pause this, write out the quadratic equation, and then come back to it. Okay, in the interest of time, I went ahead and wrote this out, but I used the quadratic formula to determine that at 2 seconds and negative 1.5 seconds, she hits the ground, the water. The only one of these that'll work is the positive 2 seconds because we don't have negative time. I would encourage you to pause this recording and work through this quadratic formula according to my notes here. And that's all I have for you. Good luck with Project 2. Thanks.